If I have seen further, it is only by standing on the shoulders of giants. Isaac Newton. 300 miles from Earth's surface, gravity begins to lose hold. Humanity has reached this point, with the giants of science leading the way.
One giant leap for mankind.
Soon, an unprecedented eye in the sky will open a window on the creation of the universe. The Webb Space Telescope will rocket 1,000,000 miles into the void. The Webb will replace the revolutionary Hubble, allowing us to see through space and time. The Webb Telescope will look backward nearly 14 billion years, giving astronomers a glimpse into the secrets of creation. Strange as it seems, this lofty arc began only 5 centuries ago, when a Polish monk peered into the sky. His theories would spark the scientific revolution and launch mankind on a fantastic voyage of exploration and discovery.
Discovery, roll program. All right, to roll, Discovery.
Since the dawn of civilization, man has gazed in wonderment at the skies. The end of the Middle Ages brought a revival of classical learning. Striving to explain human nature, intellectuals embraced the scientific method of observation and questioning. As they focused on the movement of the stars in the heavens, astronomers began to replace mythology and magic with hard science. One of these stargazers was a Christian monk named Nikolai Copernic. We know him as Nicholas Copernicus. His vision would set the scientific age into motion. Copernicus embodied the phrase Renaissance man. Cleric, physician, translator, mathematician, diplomat, jurist, economist, and governor, even a warrior. We know the name Copernicus half a millennium later, not for these accomplishments, but rather because he charted a new course for humanity. Ancient peoples believed the heavens enclosed the earth, like a theater in which gods and men acted out their roles. As far back as 400 BC, the Greeks conceived of Earth as a stationary object around which the planets orbited. Aristotle provided the physics for this understanding. Ptolemy created a model of the universe. Their wisdom had reigned for nearly 2,000 years. Even Christian dogma accepted this view. Then, in 1453, one of those rare events occurred that changed civilizations. The Ottoman Turks conquered Constantinople, queen of cities and a bastion of Greek culture since the days of Alexander the Great. The city's scholars fled west. They brought with them ancient knowledge that took root as Europe was coming into a new and questioning age. Greek and Byzantine ideas inspired Renaissance thinkers to challenge Aristotle's physics. At the same time, the Reformation was shattering Christianity, shaking loose the Church's hold on the European mind. Medieval European scholarship had largely been based on belief. Now that approach came under siege as thinkers began to use mathematical data. In their studies of the stars, astronomers had long struggled to explain what they were seeing. What caused the sun to appear to travel east to west each day? And why did the planets seem to track eastward across the zodiac? Nicholas Copernicus reasoned that the Earth might spin, causing the sun's flight. And if the Earth moved in a circle around the sun, that would explain why the sun seemed to travel across the zodiac. In so many and such important ways, then, wrote Copernicus, do the planets bear witness to Earth's mobility. But Copernicus was reluctant to publicize his ideas. The Church denounced thoughts that conflicted with its doctrine as heresy, a sin, and a crime. To fight such challenges, the Church devised the Inquisition. Copernicus had no illusions about how inquisitors might treat him and his theories. Copernicus kept his theories largely secret until he was 70 years old. His book on the revolutions of the celestial spheres was not printed until 1543. The first copy was placed in his hands as Copernicus lay dying. Soon after, European scientists began to embrace his ideas on circular orbits. In 1572, astronomer Tycho Brahe stared deeply into the sky over his native Denmark. What he saw blew his beliefs apart. Brahe was seeing a supernova, an exploding star. Before his very eyes, the universe was changing. To learn more, Brahe built an observatory. Soon, Brahe compiled data on Mars and its movements that appeared to challenge the Copernican theory of circular orbits. In 1604, Johannes Kepler, a student of Brahe's, observed another supernova. Kepler formed his first law, that planets orbit the sun not in circular, but elliptical orbits. In the spring of 1609, Galileo Galilei stood before a new marvel, the spyglass. Galileo was a devout Catholic, but he was also an avid scientist. He improved this new tool by grinding lenses that increased its range by a factor of 30. With his telescope, Galileo looked further into the night sky than anyone before. He saw craters dotting the surface of the moon and spots on the sun. Galileo saw moons orbiting Jupiter. He observed Venus moving through phases much like the Earth's moon. This information persuaded him that Copernicus was right. Just as Jupiter's moons orbited that giant planet, other planets like Earth and Venus must therefore orbit the sun. But trouble was looming. Galileo's findings were explosive. They buttressed Copernican theory, which the Vatican condemned. The questioning minds of the Renaissance were confounding the Church and its long-held teachings. With science, they had proven the Church wrong on a most basic concept, that Earth stood at the center of God's universe. The Vatican scorned Copernican theory as only offering a mechanistic means of seeing the world. Science showed how things worked, not who designed them. Determined to silence Galileo, the Vatican put him on trial. A church tribunal convicted the scientist on the charge of grave suspicion of heresy. That crime was punishable by burning at the stake. To escape the flames, Galileo partially recanted. He was granted a reprieve, house arrest, for the remainder of his life. As his sentence was read aloud, a still defiant Galileo muttered, "Yet it moves." The Church tried to smother scientific illumination, but the spark of the Copernican revolution had set fire to the European imagination. The world was changing, and there would be no turning back. In 17th century England, Isaac Newton would ask, "What propels Earth?" Newton applied the latest mathematics to matter in motion. Not only did he show that math was the language of the universe, he proved the existence of gravity. From Newton's shoulders, the next giant leap came in the 20th century. Albert Einstein introduced an entirely new way of understanding gravity, space, and time. Einstein's revelations about special and generalized relativity led scientists to wonder whether any theory could stand forever. Einstein started out thinking that the universe was static. He rejected a radical notion put forward by Georges Lemaitre. Lemaitre, a Belgian scientist and Jesuit priest, said the universe was ever expanding. He imagined a Genesis-like event in which a primeval explosion of a God particle sent all matter racing into space at terminal velocity. At first, Einstein dismissed Lemaitre's idea, but then he read the work of the American astronomer Edwin Hubble. Hubble explained the relationship between velocity and distance in a way that strongly supported Lemaitre's concept. In a public about-face, Einstein endorsed Lemaitre's theory of an expanding universe. Gradually, the scientific community came around. The Big Bang Theory, as it was mockingly called by English astronomer Fred Hoyle, seemed to be the likeliest explanation for the creation of the universe. In his research, Hubble, later known as the pioneer of distant stars, showed the universe to be far larger than anyone imagined. The Milky Way was only one of countless galaxies. These discoveries only raised more questions. Einstein died in 1955. In his wake have come clashing theories. Some say the universe did take shape in a Big Bang, that a Big Bang will destroy it. Others maintain that the universe always has been and always will be. Even so, we can clearly see how Copernicus literally turned our perspective inside out. No longer was the Earth at the center of creation. It was said that divine authority had been replaced by experience, experiment, and observation. Today's Catholic Church accepts the findings of Copernicus, Galileo, and their colleagues, largely embracing the science it once sought to extinguish. The Webb telescope will launch in 2014, replacing the mighty Hubble. This window may open onto the edge of the universe, showing us what lies at the very beginning, a Big Bang or infinity. As Copernicus predicted on a starry night 500 years ago, those things which I am saying now may be obscure, yet they will be made clearer in their proper place. To know that we know what we know, and to know that we do not know what we do not know, that is true knowledge. Nicholas Copernicus.